Anaerobic digestion is a process through which bacteria breaks down organic matter such as animal manure, wastewater, biosolids, and food waste in the absence of oxygen. Anaerobic digestion for biogas production takes place in a sealed vessel called a reactor, which is designed and constructed in various shapes and sizes specific to site and the feedstock conditions. These reactors contain complex microbial communities that break down or digest the waste and produce resultant biogas and digest the solid and liquid material end products of the AD process, which is discharged from the digester. Anaerobic wastewater treatment. Anaerobic bacteria transforms organic matter in wastewater into biogas that contains large amounts of methane gas and carbon dioxide. Energy efficient processes often are used to treat industrial wastewater that contains high levels of organic matter in warm temperatures. It can be used as a pre-treatment prior to the anaerobic municipal wastewater treatment. Stages of anaerobic digestion. Hydrolysis. Large organic compounds are converted into simple monomeric compounds. It is accomplished through extracellular enzymes. Example, cellulose is converted into starch using cellulosis. Casein is converted into amino acid by proteases. Triglyceride gets converted into fatty acids using lipases. Acidogenesis. Soluble monomeric compounds formed by hydrolysis undergoes fermentation. The product obtained due to high acidogenesis are propanoic acid and butyric acid, and which are intermediaries and others such as acetic acid, ethanol, hydrogen, and carbon dioxide. Examples of bacteria that bring about fermentation are lactobacillus. In this stage, due to acid production, the pH falls down. Acetogenesis. Some of the acetates is produced through mixed acid fermentation. Rest of the acetates is produced through secondary fermentation of products obtained in previous stage. Acetate formation is important for formation of methane. Example of acetogenesis bacteria is Acetobacter. Methanogenesis. This is the last metabolic stage in anaerobic digestion. The methane is formed either from acetate or carbon dioxide and hydrogen. The bacteria responsible for methanogenesis is called methanogens and are classified as lithotrophic or hydrogenotrophic, that is, they produce methane from CO2 and H2. Autotrophs or acetoclastic, these convert acetate to methane.
Types of anaerobic digester. Types of anaerobic digesters can be categorized according to two main criteria: by whether the biomass is fixed to a surface or can mix freely with the reactor liquid, and by the organic loading. So the first one is that the upflow anaerobic sludge blanket. It is a suspended growth high rate digester with its biomass clumped into granules that will settle relatively easily and with typical loading, which rates in the range of about 5 to 10, and it is methanogenic, that is methane producing digester that evolved from the anaerobic clarigester. The USAB reactors are typically suited for high strength wastewater, but it is still used for domestic sewage in warm climates, and it differs from other anaerobic reactors because of the existence of granular sludge with high methanogenic activity and high mechanical strength and good settling properties. Now how it works is that from the diagram you can see where the influent is having a lot of pores to come into this treatment facility, and it is fully packed as it is anaerobic in nature, and no oxygen is allowed to pass inside the reactor. So with the help of the distributors, the wastewater which is coming inside the USAB reactor is being separated out throughout the surface, and the wastewater flows upwards through the blanket and is processed by the anaerobic microorganisms. And the upward flow combined with the settling of action of gravity suspends the blanket with the aid of forklifts, and These microorganisms in the tank will attack on the organic matter present in the wastewater and thus they are digested. So eventually the aggregates form into dense compact biofilms, which is referred to as granules, and another byproduct is the biogas with a higher concentration of methane, and this can be captured and used as an energy source to generate electricity. And the heat which is produced as a byproduct of electricity generation can be reused to heat the digestion tanks. And here you can see the zone where the digestion is taking place is known as the sludge blanket zone, and what the water passes inside the area is known as the inlet zone.
Expanded granular sludge bed. It is a variant of the UASB concept. Faster rate of upward flow velocity is either accomplished by utilizing toll reactors or by incorporating an effluent recycle for the wastewater passing through the sludge bed. The increased flux permits partial expansion of the granular sludge bed, improving wastewater sludge contact as well as enhancing segregation of small inactive suspended particles from the sludge bed. It is appropriate for low-strength soluble wastewaters or for wastewaters that contain inert or poorly biodegradable suspended particles. Anaerobic filter. The digestion tank contains a filter medium where anaerobic microbial population can establish themselves. They produce a less solid residue than other types of filter. Upflow anaerobic hybrid reactors. It involves the introduction of a new phase of attached biomass into a regular suspended growth system. It contains both suspended and attached growth biomass, which is developed by introducing porous materials into a regular activated sludge unit. It combines a UASB reactor with an anaerobic filter. This combination is an advanced form of enabling improved solid retention time in the treatment of wastewater. This wastewater can be built up in the secondary chamber and must be removed daily. Fluidized bed reactor, a type of reactor device that can be used to carry out a variety of multi-phase chemical reaction. Fluid is passed through a solid granular material at high enough velocities to suspend the solid. This process, known as fluidization, imparts many important advantages.
Merits: high degree of waste stabilization, low production of excess biological sludge that can be directly dried on sludge drying bed without further treatment, low nutrition requirement, no oxygen requirement, production of valuable byproduct methane gas, etc. Organic loading is not limited, less land requirement, no feed condition for few months do not affect adversely to the system. Disadvantages: incomplete breakdown of organic compounds, no thorough nutrient removal. Again, later anaerobic purification with nutrient removal is often needed. Most efficient purification is the mesophilic range 30 to 37 degrees Celsius, whereby the influent must be heated in most cases. Less robust system with regards to toxicity and inhibition risk of odor problems. Advantages of anaerobic digesters: it produces methane and carbon dioxide which can be collected and used as fuel, reduces the volatile content of sludge. Liquid is more easily dewatered as liquids and solids forms different layers. Reduction in number of pathogens. Disadvantages: needs constant supervision, formation of explosive gases not easily controllable, maintenance and cleaning is difficult. It is a slow process.